Hello everybody, so today in this video we are going to discuss this question least prefix sum which is asked in Hello 2023. In this question we are given an array A1 से AN and we have to do some operations possibly 0 times. What we have to do is we can choose any index I and we can change its sign. Suppose at the fifth index the value is 3, so we can make 3 minus 3, or let's say suppose at ninth index the value is 5, so we can make 5 minus 5 or minus 5 as 5. And by doing these operations what we have to do is we are also given a number m, so by doing these operations we have to minimize the value of a1 till am sum from a1 till am. But there may be many other prefix sums. As you can see, a1 till am is the prefix sum of first m numbers. There can be many prefix sums having the same value, but this value, the sum a1 to am, should be the smallest value. So let's understand the question with the help of some examples. So here in this example we can see the first example as we are given 6 test cases, and in the first example we are given the size of array is 4 and m is equal to, we are given as 3, and we are also given as -1, -2, -3 and -4. So what we have to do is we have to minimize the sum. We have to minimize actually this sum which I had marked with green. We have to minimize this sum. So let's first find out the prefix sum. The prefix sum would be -1 plus -2 is actually -3, then -6, then -10. That is this green sum should be the minimum value among all the prefix sum. This green sum should be the minimum value among all the prefix sum. We can see that this -6, that is sum of these three numbers, is smaller than -1, okay, is also smaller than -3, okay, but is greater than -10. So what we think of is, let's say we do this -4 as +4, we convert this -4 as +4. After converting this -4 as +4, this -10 gets converted to -2. If now we will see that the -6 is, as we had seen that -6 is smaller than -1, -6 is also smaller than -3, now -6 is smaller than -2. So number of operations required are 1. In one operation what we have done is we have changed this 4 to -4, and now the sum of first three numbers become minimal, and the number of operations therefore required are 1. So here you can see the answer is 1. In the fourth test case, let's see. In the fourth test case, let's find out the prefix sum. This test case 5, 5, 2 minus 5, we are in which given m is equal to 5 and there are 5 numbers, -2, 3, -5, 1, -20. It would be -2 plus 3 is actually 1, -4, -3, -23. We can see that the fifth number, that is of the prefix sum, that is -23, is smallest among all the values. So what we can say is that this is suitable, and we don't require any number of operations. Or what we can say is, if suppose in place of -4 it is also -23. Suppose after finding the prefix sum, somehow we got that -2, -1, -23, -3, -23. Then also what we can say is, then this is also valid and we don't require any number of operations, then also number of operations would be 0. So let's try to understand how we will solve this question. So let's take some example to understand how we will solve this question. Let's take last second example, -2, 3, -5, -5, -20. It is 5, 2, -2, -3, -2, 3, -5, -5, 20, -2, 3, -5, -5, and it's -20, I think. -20, yes. what we have to consider is we have to consider the first two terms. Actually, in this we have to consider the first two terms. So that is, we want to minimize the sum of first two terms. So let's first find out the prefix sum and see prefix sum. It's actually -2, then 1, then -4, then -9, then -29. We can, what here we can observe is that is the prefix sum of first two numbers, that is 1, is is not the minimum actually among all of them. So what we need to is need to actually minimize this, the sum from all the numbers from 1 till m. So another observation what we can make it is, suppose let's say this is the prefix sum. Suppose I decided to make, I'm marking this -5. Suppose I decided to make this -5 plus 5. I decided to make this -5 plus 5. I made this -5 plus 5. So let's first observe the change in prefix sum. What the change shows, prefix sum shows. So the new prefix sum would have been, it would be -2, then 1, then it is 6, then it is 1, then it is -21. So let's first observe the change. When we change this -5 to +5, we can see that the -2 remains same, 1 remains same, this -4 becomes 6, this -9 becomes 1, and this -29 becomes -21. It means, if you carefully observe the differences, this was incremented by 10, this was also incremented by 10, and this is also incremented by 10. It's actually -19. Okay. This is also incremented by 10. So what we can observe from here is, what we have changed is, we have changed -5 to +5. What we can observe is, if we change any number, suppose we change x to -x, then the prefix sum, the prefix sum values further, the further prefix sum values here, this is the further prefix sum value, this is the further, that is the, we have changed at this point. From that point onwards, all the values of the prefix sum from that point onwards, I have changed -5 to +5 here. So from this point onwards to all the other points which are ahead of it, all the values are incremented by, suppose we had made x to -x, so all the values are incremented by 2x, all the values are incremented by 2x. It's depend on ±2x, but all are changed by 2x. What I mean to say is, either they are incremented or decremented by 2x depending upon the scenario. Here they are incremented by 2x. And vice versa, it might be possible that they are decremented by 2x. So the change of 2x will take place. You can observe, if we change x to -x, or you can even see that the difference between x and 2x is, x and -x is also 2x. So if we convert x to -x, let's say first -x to x, where x is greater than 0. Wait for a second. So if we convert -x to x when x is greater than 0, then there would be a change of, then there would be an increment of 2x. And if there is a change from x to -x, when x is greater than 0, then there will be a change of minus of 2x. From that point to all the points which are ahead of it in prefix sum. So we also follow this observation. So this is the observation number. Let's say it is 1. So let's again come back to the example -2, 3, -5, -5, -20. It is -2, 3, -5, -5, -20, and we have to find the sum of first two. So prefix sum would have been -2, 5. It's actually -2, 1, -4, -9, -25. So let's come up with the second observation. So the second observation we can make is, let's say let's say there are a series of numbers, and what we have to do is we are at middle, and we can see that the middle value, suppose at any position in the, not exactly in the middle but at any position in between, and we can see that this is not the minimal value, not the it's actually not the minimal most value, or that is this prefix sum, that is the sum of these elements, is not the minimum value. So what we here we can observe is, if there is some positive number, if there is some, and let's say and another thing is, there is a value, this value, which is more smaller than this black value. Let's say this is my black value, this is my black value, this is my green value. Let me change the color. This is my green value, and let's say this is my another value. Let's say this is my blue value, this is my blue value. So what I can say is, this I am actually saying is, this green value is actually smaller than this black value, and this blue value is also smaller than this black value. Again I am repeating, I am saying that this green value is smaller than black value, and this blue value is also smaller than black value. What actually this green value, black value and blue value represents is, the black value represents the sum of all the elements from 1 till this black value. The green value represents the sum of all the elements from 1 till this green value, and the blue value represents the sum of all the elements from 1 till this blue value. So blue value represents actually this 1 till blue, green actually 1 till green, black till means 1 till black. That is the first index till the black element where it is present. This is actually the representation. I am saying this green is smaller than black and blue is also smaller than black. And another thing is, let's say there are some positive integers. Here there are some, might be 3 to 4, or I can say 1 positive integer. Considering this slot, I am marking the slot with purple. It might be possible that this black number is might be positive or negative. So might be positive or negative. This black number is also might be positive or negative. Or let's say in this section, let's say in this section we have some negative numbers. I'm not, again I'm repeating, let me mark it as section 1 and section 2. This is my section 1 and this is my section 2. I'm again repeating, when I'm saying section 1, then I mean to say is, it contains some positives, some negatives. But I'm saying, let's say there are positive numbers. I'm not saying that there are only positive numbers. This section 1 might also contain negative numbers. So what I'm saying is, let's think that there is at least one positive number. And what you can think is, if green is smaller than black, think wisely, if green is smaller than black, then don't you think after the green, that is, let us say green is at the ith index, then from the I plus 1th index till the black index, from the I plus 1th index till the black index, there must be a positive number, so that which led to black greater than green. Don't you think? Again I am repeating, from, let's say green is at the ith index, then from the I plus 1th index till the black index, don't you think there will be any positive number, because of which the black is become smaller than green? Because if all the numbers which are marked in this section 1 are negative, because all the numbers which are marked in this section 1 are negative, then black would be smaller than green. But here black is greater than green. It means from the I plus 1th index till the black index, including the black index. I mean saying including the black index, there might be a positive number which is bigger, because of which green is smaller than black. So here I can say there positive means there is a large positive number. Let's now consider section 2. In section 2, I am not considering black. I am saying if black is at, let's say, jth position, so I am considering the j plus 1th position. So from j plus 1th position, till the blue position. From j plus 1th position till the blue position. I am considering from the j plus 1th position till the blue position. What I am saying is, if there are negative numbers, if they, let's say there are positive numbers, from the j plus 1th position to the blue position. If there are positive numbers, don't you think, let's say there are only positive numbers, let's say this, so then don't you think that black will be smaller than blue? Of course black then will be smaller than blue, but where here we can see is blue is smaller than black. So it means in this section 2, that is from the j plus 1th index to the blueth index, we can say there is a strong negative number, there is a strong, or I can say big negative. Big negative means, by saying big negative, I mean to say is minus 63 is big negative as compared to minus 2. So I can say there is a strong negative number, because of which this blue value is actually smaller than this black value. So from this I can make a conclusion that if I make section 1, it means from here we can easily be able to show that in section 1 there is a positive value. What I mean to say is there can be so many positive values, but I am sure that there is a positive value. It is not that that there are only negative values in section 1, there will be a positive value. And second thing which we are confirmed about from this observation is, in the section 2 there will be a negative value. It is not that there are no negative values in section 2 and blue becomes less than black. It's not possible. There will be some negative values in section 2 because of which blue becomes less than black. So from in section 1, what we can observe, what we can say is, there are positive bigger values. In section 2, what we can say is there are negative strong values. So don't you think if we consider these positives to these negatives, positives to negatives, and if we convert these negative to positive, I convert section 1 positives to negative. So don't you think, I am saying that I will not convert all of the positives to all negatives, but let's say I convert some of them. So don't you think, what I am actually saying, I am repeating, that I convert section 1, some positives of section 1 to negatives. So don't you think that black value will become less than the green value? And if I convert some negatives of section 2 into positives, some negatives of section 2 into positives, then don't you think that my blue value becomes greater than black value? That is, green will become greater than black and black will become lesser than blue, because of which, don't you think so? And don't you think this is our target only, that green should become greater than black and black should become lesser than blue? So this is our second observation, that we have to convert these positives of section 1 into negatives, and we have to convert the negatives of section 2 into positive. Not all negatives into positive, but some of them for sure. These are observation 2. So we had made 2 observations. The first observation is change of 2x, and the second observation which we had made is which section we have to change. So here we will use the concept of priority queue to solve this question. And another important observation which we can made from the second observation is, don't you think if I want to change a positive value into a negative value in section 1, so what I have to do is I have to first change the maximum positive value into the negative value. Don't you think this would be the optimal approach, and this would be the better approach if I first change the maximum positive to maximum negative, because of which my number of operations are required would be minimum. And similarly in the section 2, if in the section 2 I want to convert the negatives into the positives, then don't you think I must convert the highest negative into the positive, so that blue will becomes, that is the blue value will becomes greater than the black value. So this is an important note that we must change the highest one, and as we are required to change the highest one, so we require two types of priority queue, because at every instance priority queue can gives us either the max value or the min value. So we require two priority queue, one is max priority queue and other is min priority queue. If let's say this is my black value, this is my green value, and let's say this is my blue value, here I need to convert the positives into negatives, and here I need to convert the negatives into positives. So for converting these positives to negative at every instant, I want the maximum positive. So if at every instant I want the maximum positive, so here I will use the max priority queue. And here at every instant I want to convert the negative into positive, so at every instant I will use min priority queue, which will give the minimum value, or I can say strongest negative. I am saying the minimum value is the strongest negative. So these are the two things. So how we will be using priority queue? Let's discuss that. So let's say we will take the example of this only: minus 2, 3, minus 5, minus 5, minus 20, minus 2, 3, minus 5, minus 5, minus 20. First we will find out the prefix sum. So prefix sum will be minus 2, 1, minus 4, minus 9, minus 29. Let's so what we will do is we will say, okay, this is my m is equal to 2. I am starting from this, my pointer is at this point, and I will move towards this direction in the first stage. In the second stage, my pointer will be towards this at m plus 1. Currently my pointer is at m and I will moving towards left direction. After that my pointer will be at m plus 1 and I will move towards right. So let's first consider the left case in which I have to move left. My pointer is at m is equal to 2 and I will move towards left, and I will move towards left. Okay, my pointer is at m is equal to 2 and I will move towards left. So what I will do is, okay, I will go through each one. First I am seeing 1. Okay, at m is equal to 2 I am seeing 1. I say, okay, 1 is not smaller than 1. If 1 is not, so let's say first I make a max priority queue here. This is my max priority queue. Max priority queue. Okay. So first I move to 1. I say, okay, my 1 is actually not smaller than 1. My 1 is not smaller than 1. So I will say, I will push this value, this 3 value into the max priority queue. Then I move to minus 2. When I move to minus 2, I saw that my minus 2 is actually smaller. My minus 2 is actually smaller than 1. So I will ask max priority queue, what is the maximum positive value you had achieved till now? So max priority queue will say, okay, the maximum positive value which I had achieved till now is 3. So what we will do is we will remove 3 from the max priority queue. We will remove 3 from the max priority queue. And in this one, actually what we are doing is, when we are traversing now, we are actually storing the value at this value, that is the m is equal to 2 value at some place. We will actually store this m is equal to value. Let's say we had made a variable val and we had stored this value that m is equal to is 1, because this value at m is equal to 2 will constantly be changing, because here in this example you can only see that there is only minus 2 is actually lesser than minus 1. Minus 2 is actually lesser than 1, but when we move more left, you can see there are so many prefix sums which are lesser than the prefix sum of till m. So In that case, we have to constantly update our values. So we will actually not update them in the prefix array. We will actually update them in the variable, as because we every time when we move towards left, we will compare every prefix sum with actually the prefix sum of m terms. And we are actually saving in this val. What I'm saying saving is the prefix sum of m terms. In this val, what I'm saving is the prefix sum of m terms. So remember for now this. So I moved towards left. I found that -2 okay is smaller than 1. So I had asked priority queue that which is the largest positive value, which is the largest value which you got till now. So he said the largest value which I got till now is 3. So what I will do is I will add, okay, let's see it clearly. But I will add minus of 2 into 3 into this val. Why minus of 2 into 3? We had the 3 which you can see here is, we will convert this 3 to -3. The 3 which you can see here is this 3. We will convert this 3 to -3, because of which the -1, you can see, if we convert x to -x, then what will happen? If we convert x to -x, then all the values are changed by minus of 2x. It means this one, what we will do is 1 minus 2 into x. This one, this val, you can see in the val, what we had done is, we had done 1 minus 2 into x, because this one. So actually in real I am not converting this 3 to -3. In real I am not converting this. Just to explain you how the things work, I am saying, let's think of in your mind that I converted this 3 to -3. Then all these values are changed by -6. That is, we will decrement -6 from all these values. That is, we will decrement -6. But there is a decrement of -6 from all these values. So our prefix sum becomes 1 minus 2 into 3, that is -5. That is become -5. So in the future, suppose I move towards more left and I found that there is a negative value. So what I will do is I will compare that value. I will compare that value not with the value at m, that is 1. And now I will compare it with -5. This -5. Now I will compare it with -5, that whether it is smaller than -5 or whether it is greater than -5. If it is smaller than -5, then in the priority queue there would be some positive which I had to convert to negative. So this is the work of my left section. Let's clear some stuff so we will understand the work of the right section. This is actually +3. Okay, so let's understand the work of the right section. You can think of that, if we had changed the value at this point, all the values get changed. So changing or no changing actually doesn't matter. Suppose, what I mean to say is, if you had changed something on left, that is, you had made 3 minus 3, then all the values on the right side get changed. So if all the values are changed by the same value, actually we had not done the change. That's why I am comparing the values when I'm moving towards left with val, not with the actual prefix sum of first term values. So let's now first focus on the right section. What the right section is actually saying. In the right section, I will start from let's say this is the mth index, m is equal to 2. I will start from m plus 1. Why m plus 1? Because I want to put the maximum negative value. And what I made is min priority queue. Min priority queue, in the top of min priority queue, there should be a negative value, which is the strongest negative. So suppose that m is equal to 2. Instead of 3, I am saying instead of 3 here, in the initially, question is given to be -3. Suppose that m is equal to 2. Here at initially question is given is the -3. So so we put minus, let's say we put minus 3 in the min priority queue, and say after some steps we will see that the minus 3 is at the top, that is minus 3 is the minimum most value in the min priority queue. So don't you think we will convert this minus 3 to plus 3? No. Why? Because if we convert this minus 3 to plus 3 later on, so because of which my left section will get disturbed. So I will not start from m is equal to 2, I will start from m is equal to 3. So okay, so I will start from m is equal to 3. I can say, okay, this minus 5 is the negative value I got. Okay, I will first say this. Okay, this minus 4. This minus 4 is actually smaller than 1. So, first I will say this minus 4 is smaller. First I will put minus 5. I will put minus 5. Then I will see, okay, this minus 4 is smaller than 1. So, I have to convert this minus 5 to plus 5. If I will convert this minus 5 to plus 5, so how all the values are changed? So here also I will track with the help of val that if I'm here, I am considering actually minus 4. Okay, so if here I am considering minus 4, so I will say, okay, let's, I have changed minus 5 to plus 5. So there will be an increment of 10, 2 into 5. So I will say, okay, this becomes minus, this becomes 6. So I will say, okay, now I've changed this, so 6 becomes greater than 1. 6 becomes greater than 1. So then when I move to minus 9, I will not compare minus 9 and 1. I will do is, val is actually minus 9 plus 10. Why plus 10? Because this change of minus 5 to 5 on minus 4 will not only for minus 4, this minus 5 I have, let's say, changed to plus 5. So this change is not for this only, this will for this also, for this also. So I will say, okay, minus 9 plus 10, this is 1. Is 1 is smaller than 1? No, 1 is equal to 1. So I will not make any change here. I will just put minus 5 and not make any change. This minus 5 gets used up, therefore I am removing it, and here it contains this minus 5. Now I am pushing actually this minus 5. Now I move to minus 29. I will say, okay, val my is minus 29 plus 40. Okay, sorry, minus 29 plus 10. Because of that minus 5 which we had removed, so it will be minus of 19. We can say, okay, minus 19 is still smaller than 1. Before that I have already put minus 20. So okay, I will see minus 19 is smaller than minus 1. So what I will say is the smallest negative is strongest negative is minus 20. So I will say, okay, let minus 20 change its sign. So if minus 20 will change its sign, so my value minus 19 becomes minus 19 plus 40. So it will become 31. It's actually 21. So it becomes 21. So I will say now 21 is greater than 1. So in this way we can maintain that how many changes we had made. We had actually, you can see we had made 3 changes here. First, when we convert that plus 3 into minus 3. Second change which we had made is when we convert this minus 5 to plus 5. And the third change we had made is this minus 20 we had converted to plus 20. So you can see that we had made 3 changes. So answer to this is 3. You can see that last second value is 3. So we had made 3 changes. We had done actually 3 changes. So let's understand this with the help of some code section. So here you can see I had found out the prefix sum. Then I had clearly changed the sign of any value led to the increase of minus of 2 into y, or depending upon the scenario you can easily able to think of. It's actually minus of 2 into y. If ai is negative, it becomes 2 into ai. If ai is positive, it becomes minus of 2 into ai in each value in RHS. Then this is the whole section which we have to do. You can see there are 2 for loops, and the great thing is I traverse from I is equal to m to I is equal to 0. And in the second section, I have traversed from I is equal to m plus 1 then till I is equal to n. Second is which you can observe is, I will say, okay, let's say prefix sum of I is less than prefix sum of m plus val. When I explaining in the video, I had made the val different, but here I am saying that I have added prefix sum of m plus val. So don't get confused, these are actually two different things. I know that these are two different things, but you can apply any of the methods which I explained you in the video or which I had written in the code. Actually, when I am explaining you, I have incorporated prefix sum of m in the val, but here I have shown you in the section which I selected, I have take prefix sum of m different and val different. So I don't think there is a need of there is a confusion. There will be any confusion, and in the second section, here you can see in this section that first actually I is m, so we will first check whether prefix sum of m is less than prefix sum of m plus val, and initially val is 0, so prefix sum of m is less than prefix sum of m, it says no. So initially what I have done is we had pushed back v of I, that is v of m, and here first we had pushed back. After that we started the checking. And we had incremented the val minus of 2a, and here also minus of 2a, and at the end you can see that at every removal of value from the priority queue, I have incremented the answer, that is the minimum number of operations. In this also, in the above also, I have incremented the answer with every pop. So we will return the value answer at the end. If you like this video, do share and subscribe. Thank you.